engineering friends. Using the potential from process history data to operate the process in a more stable, efficient, and optimized way has become the necessity for the plants of the future. Industry 4.0, Industrial Internet of Things, Big Data. These are all just fancy words that stand in front of the raw, real, and huge amounts of process data stored behind every industrial process. Those data will remain only a pure potential if not transformed into process solution. Because of this, using the process data in a simple and practical way should be the primary knowledge of every chemical engineer and engineering in general. Not only using those process data, but also be able to understand them, recognize the opportunities they offer, turn them into solutions, and use that solution for the benefit of process safety, improved process operation, and improved economy. And this is all that we learned with the course Process Optimization with Predictive Analytics 10 Days Challenge. This is a short excerpt from it.
We start by getting familiar with different applications of predictive analytics. Every challenge has an assignment which you need to finalize based on the lesson you take. Then we go into details of 3 process sections, and they are distillation columns, reactor, and the fire heater. You choose on which one you'd like to work on. You get all the details of the process, its process flow diagram, process description, and larger set of data that you will work on. After that, the real game begins. How do I find all the opportunities? There are 4 directions from which we should look for the opportunities. The first one is from the process flowsheet point of view, starting from equipment. Till now, we have learned what sections offer the best opportunities for improvements and optimization. So just look for them. Easiest way to do is to look into the flowsheet. The second direction is from the product quality point of view. Quality prediction is one of key parameters of any unit, and we want to find out how it can be improved. Third direction. At the end, it is all done to show some economical benefits. But economical benefits could be also a very good place to start, looking into prices, costs, losses, giveaways, energy prices, etc. The fourth direction are operational problems. Here it's good to be gentle and careful because very often people don't want to talk about operational problems. Although they can become opportunity number 1, it's better to leave them for the end, because most probably you have already discovered what operational problems are through first 3 directions of looking for opportunities. Always be gentle when addressing operational problems. By this stage, you have already done your first 3 assignments. They were checked for you, corrected if needed, and approved. So you are ready to start the exciting part of the 10 Days Challenge course, looking into data, process description, and the process flow diagram, and analyzing all the documentation to reach the goals we have set. We are looking into available tools for building models and install the open source one that is robust and easy to use to help us create our models. At first, we experiment, and then with the challenge number 8, we create the real, functional model that is able to improve the operation and optimize the process. You are fully guided all the way by lessons, instructions, solved examples, and corrections of your assignment. The end of the 10 Days Challenge course is dedicated to possibly most important thing of the whole course, looking into the benefits of your solution, calculating the return on investment, and presenting it as a business solution to your client or your colleagues. The last example is fire heater. Our average for operating data is 6%. Again, here also be careful about specific conditions. However, our data did told us that average absolute error that can be expected is 0.3. With that result, we can be confident that it is possible to reduce overall variability of excess oxygen in flue gases, and let's assume we can have it less than 1.5%. With this in mind, and with the O2 safety requirement of 3% in mind, it means that we can be safe with the limit of 3.5%. That means controlling the stack oxygen around 3.5% without being in risk of violating the limit. Since the oxygen requirement is usually 2%, this means that we probably can even go down a bit more. But let's stay safe around 3, meaning 3.5%. By decreasing oxygen for 0.5%, it decreases requirement and decreases fuel consumption to around 1% fuel gas, which can be saved. This can be multiplied, of course, by the concrete price to reach the final saving estimation of fuel consumption per year. Your challenge here is really to tell the story with the data, and these are the numbers that can be put into an exciting story that can bring a lot of attention. So to present your story of improvements and possible saving, you can do it with a study, with a presentation, or in your everyday conversation with your colleagues and customers.
You can do your 10 days challenge in 10 days, in less than 10 days, in a longer time than 10 days. You set the rhythm and you take your time. We had one very dedicated student who was able to finish it perfectly in 7 days. We as well got excellent reviews from students who finished the course that are happy with the support and interactions and wide knowledge they are able to apply in practice after that. Nothing is more rewarding for the instructor's ears than hearing words of praise. So I hope that you will join us, find out more and apply using the links in the description below. I hope to see you during the course, and that was it for now. Thanks and bye-bye.